Hello everybody. In this video I will discuss with you the drug I chose, which is methamphetamine. I chose methamphetamine for two reasons. One is because I recently finished watching the show Breaking Bad, which is about a chemistry teacher diagnosed with cancer, and to pay for his treatment he begins to cook and sell methamphetamine. Another reason is that it's a drug with high prevalence and usage in Kern County, so I wanted to understand it better, how it affects the user, how it interacts with their body chemistry, and what causes it to be so dangerous. Now on to information about meth. Methamphetamine has a melting point of 170 degrees Celsius. Methamphetamine also has many names, from its IUPAC name being N-methyl 1-phenylpropane 2-amine. Meth also has more commonly heard street names such as crystal meth, ice, speed, crank. Its medical names, its trade names in a medical sense are called desoxin and methadone. The structure of methamphetamine here looks quite similar to a chemical you'd see in class. Just going over it, on the left side we have a benzene ring, on the right side we have an amine, which also has a methyl attached, and then on the bottom we have a methyl, which is quite important how the chemical behaves. And right here in the middle, we have a stereo center, with the left side going towards a benzene ring, the right side going towards an amine, the bottom going towards a methyl, and the top going towards a hydrogen. An important feature to point out from the chemical is that the stereo center causes the chemical to be chiral, meaning that it has two enantiomers, and that depends on whether this methyl points towards you is R or points away from us is L. If it's L, then it's levoamphetamine, which is a over-the-counter nasal congestant. And if it's R, then it's methamphetamine, which is a Schedule II class drug. The difference in effect is because the methyl, if it's L, is surrounded by the rest of the chemical, and if it's R, is easily accessible. And while I'm going over similar in structure but different effects, another is Adderall. Adderall, or amphetamine, is an over-the-counter stimulant that is used to treat ADHD. What sets meth and Adderall apart structurally is that Adderall has a hydrogen bond attached to the amine instead of a methyl group. Both Adderall and meth actually have similar effects, as both are stimulants that can be used to treat ADHD, decrease hunger, and increase energy. The drastic difference in effect in meth has to do with how methyl enhances the strength of meth and allows for the brain to release much more dopamine into the brain. What basically happens is that meth will interact with the interceptors in the brain that control the amount of dopamine that can release in production, so dopamine overall increases. The reason I mention this is because when I show the 3D structure, I will be using Adderall instead of meth. For the most part, while methamphetamine can be used medically, it's mostly used as a recreational drug. Meth will interact with the brain and release high amounts of dopamine, which is the chemical that gives pleasure reward, as you can see on the image. This is what causes it to be highly addictive. It will give a quick and short high, but after a while the user will crash. This crash is where the term tweaking comes from. Other effects are increase in energy, decrease in appetite, faster breathing, rapid heartbeat, increase in blood pressure, and body temperature. I won't be going over the long-term negative effects as that is beyond the goal of this paper. Methamphetamine is a molecule that can be created synthetically. There are a few different ways to produce meth depending on what reactants and processes are used. I will show two different processes to create meth. The popular method for meth on the streets uses cough medicine, pseudoephedrine, which is an easier method as it is made in homemade labs throughout. The second method is a reductive amination reaction, which most chemists will follow to synthesize. As we can see here, we have two different syntheses. I'll start with the top one first. On the top, the reaction begins by using phenylacetone first. It is reacted with methylamine and formic acid to form this next compound. It adds the methylamine right here and the formic acid onto the amine. Next, you will react it with more formic acid and it will add onto this double bond next to the amine. The next, the oxygen will remove itself and add CO2 onto the side. And for the last reaction, we'll react it with an acid such as H3O plus or even HCl, and we'll remove this compound on the right side, leaving you with the racemic mixture of RNS methamphetamine. On the bottom, we can see we have S-pseudoephedrine synthesis. To start, this is the method that will be used in most illegal operations. To start, they'll get cold medicine and extract the pseudoephedrine from the cold medicine. Next, they'll react it with hydroiodic acid, and the hydroiodic acid, the H will react with the OH, making it into a water, turning it into a leaving group. Next, the iodine will come in and react, forming an I leaving group. Next, it'll react with HI to pull the iodine off of that, and you'll react it with red phosphorus. After that, you'll be left with an R methamphetamine. Here are the references I used for my paper. The two highlighted ones are the ones that I used to help me create the synthesis for methamphetamine. Now we'll be looking back on how methamphetamine interacts with the brain. In the ventral striatum, in the nerve areas where dopamine is produced and interacts throughout your body, in a normal state, your body won't have too much dopamine passing around in between the nerves in that sense. But once methamphetamine is introduced, methamphetamine will interact with the receptors, it'll interact with the transporters, and it'll start flooding your brain with dopamine, giving you that euphoria high feeling. Now we are on the RCSB website and we will be looking at 4LAR. In this, we will see a single chain antibody in complex with amphetamine. I wasn't able to find an RCSB for methamphetamine, but as I went over earlier, amphetamine is related enough to work. The model takes place in a common house mouse. What the antibody does is it interacts and sequesters the amphetamine and halts the increased production of dopamine in the brain. Here we can see the 3D model in the RCSB website. And as you can see, this is a single chain antibody for 4LAR. And on one end right here near the edge, we can see the amphetamine atom. As we get closer, we can see how this amphetamine molecule interacts with its neighboring atoms. On one end, you can see how the nitrogen interacts with the 5-membered plane ring, and the plane will stay parallel to the nitrogen. On the other side, we see a 6-member benzene ring on the other side of the nitrogen interacts and stays planar to the nitrogen. And on the other side, here we can see an oxygen from a carboxylic acid functional group interact with the nitrogen. Now we are on Chimera and we will look at amphetamine's active site from 4LAR. Of note is that the top part of the molecule is where the amphetamine will come from. When the amphetamine gets to the antibody, it will move into the gap and become trapped. So as you can see here, the amphetamine will come from this top hole right here and it will become trapped. And then it will become pretty much stuck in this interaction by this oxygen will interact with this nitrogen. And then all these benzenes along will trap it. And that's how the amphetamine is sequestered from the body and how it stops reacting with your brain. Here we can see a close-up of the interactions of molecules that interact with amphetamine. It's not too much going on, It's only three different molecules, but what happens is that this molecule, the oxygen directly interacts with this nitrogen, and on top of that, this six-membered benzene ring will form planar to this nitrogen and interacts with it that way. And on top of that, if I could angle it, we also have this five-membered ring on the part of this molecule will form planar to this nitrogen. Other than that, there aren't too many